So with that, I'm going to hand the mic over to you, Rena. Take it away.
Okay. Thank you. Thank you, guys. Okay. So I want to thank you guys for staying with us, and we're going to try this again. Okay, so we're going to cover how lighting affects health, safety, and our welfare. This is an HSW credit. So let's get started. So the main focus of this presentation is to navigate us through how lighting can affect our architectural environment and the three terms in terms of health, safety, and welfare. So we're gonna cover circadian rhythm lighting, flicker and glare in the health section. We're gonna cover safety, that's actual safety and perceived safety in interior and exterior environments. And then for welfare, we're gonna cover dark sky, color, temperature. So to get started, we're starting in the health section. So one of the most recent discoveries has to do with the newly discovered receptor in our eye that's not really used for vision. In addition to the classical photoreceptors that we're familiar with, which is your rods and your cones, this receptor, the IPRGCs, and I'm sorry, I don't know what that stands for, but I will look it up afterward, are present, and you can see it's highlighted in blue in this slide. They're found to be responsible for entertainment of circadian rhythm lighting. So the non-visual photoreceptors in our eye are more sensitive to specific wavelengths on the blue side of the visible spectrum. So you can essentially see that. The blue turquoise light, which is essentially 456 to 490 nanometers, is more efficient to regulate the circadian rhythm lighting. And blue violet light, which is 415 to 455, medical researchers show that blue turquoise light may be less damaging than blue violet light, which brings on age-related macular degeneration and digital eye strain. So here you can see there's an application for a hospital environment, and we're showing like lighting throughout like a 24-hour time period. And you can essentially see the circadian rhythm lighting. And essentially, this study shows that the kind of dynamic lighting strategy that can improve the recovery of patients, suppressing the melatonin production during the day and enhancing the melatonin production during the evening or nighttime, and essentially allowing for a quicker overall recovery. So flicker. Flicker is one of the most common problems we encounter nowadays, specifically due to the LED era. I'm sure you've all seen like flicker-related situations in the past, and it's a big problem, and it depends on a wide variety of factors. But generally, the three main ones to be considered is the power supply and the quality of the power supply, the compatibility of the fixture with the driver or the power supply, and the compatibility with additional accessories like heat sinks and whatnot. It's important to touch base on a key flicker factor, the power that we get from an outlet, which is the AC or alternating current with an incandescent source. The resistor of the filament made it almost impossible to notice flicker in the past. It sort of acted as a buffer. Unfortunately, nowadays, we power our light sources may have a huge impact on flicker because the DC current or the direct current will substantially reduce the flicker on most light sources, while an AC current will likely produce way more flicker as there are moments of zero current. This does not happen in DC. So again, this is like kind of the age-old conversation about direct current or DC versus alternating current, low voltage versus line voltage. So this is really, this is that age-old discussion. Do I want like ease of install or do I want perfect dimming? Or not just perfect dimming, but do I want a flicker-free environment under every circumstance? And this is kind of the obvious question that lighting designers have to think about when they're designing spaces for any application. So Some of the most common health-related problems with flicker, and these are minor, but they do become very annoying, which is headaches, eye strain, and fatigue. And the question is how to know when there's flicker, and the answer is anything blinking under 100 hertz, our eye will not perceive as flicker, while standards accept up to 90 hertz. A couple ways to notice or test for flicker is to use our camera on our cell phone and try to identify banding, which you can see on the far left. This is potentially a good way to identify flicker from a light source. The banding effect occurs when the light source on or off is in synchrony with the frame rate of your camera. But there's a trick: you need to know the frequency of your camera taking photographs, or like the video frame. The most practical test is to flick something like a ruler in front of the light source. If you see like a strobing effect, the flicker is probably below 100 hertz and will be a visible flicker. On the other hand, if you see the object move without the strobe effect, the light source is probably flicker-free. Some of the health effects associated with this. So there's like the obvious stuff, which is blurred vision, eye strain. It's not that big of a deal in most circumstances, but it's very annoying. But it can become very dangerous in like a driving situation. Headaches, migraine, fatigue, and the reduced visual task performance, which can be quite serious. And then, of course, is the full end of the spectrum, which is like neurological effects, epileptic seizures, et cetera. So it's a very big deal, light flicker. It's not just something that's just a little annoying. So how to avoid flicker? So follow these recommendations. You need a good quality driver. You need to replace all your old lamping, and all the parts and fixtures of the system need to work properly. That's like your heat sink, your driver, et cetera. Glare. So glare is defined essentially as light right inside your eye that makes you sort of squint. I think there's a better terminology for that. But let's imagine all the point sources on the image have the same lumen output. So what you're seeing in the left-hand picture are 4 different point sources. The smallest one has the most glare, essentially, because it's the smallest surface area to dissipate all the lumens. The larger the glare, the larger the surface, the less the glare. Now we're moving on to different ratings. So this is how glare is measured. There's essentially 2 different terminologies. One is called your VCP, or Visual Comfort Probability, and the other one is your UGR, which is Unified Glare Rating. Because we're American, we always like to have our own ratings. VCP is generally used in the United States, but if you are looking at specifications for lighting products that are global brands, you're going to find your UGR rating or Unified Glare Rating. These are just 2 essentially different rating systems. They actually tell the same story, and if you Google VCP to UGR, you can actually find how to decipher between the 2. You can take the value of a product in VCP and translate it to UGR and vice versa. The one that I think is probably most important is the Unified Glare Rating. And generally, this is really, really important for street lighting, office lighting, anywhere where there's tasks being performed. This is mandated, the UGR rating and the VCP rating. So VCP, one thing that's important to know is that VCP evaluates the percentage of the observer population that will accept the lighting system and the environment is not being comfortable, while UGR systems predict the level of discomfort produced by a glare source. So that's kind of just the differences, but they both tell the same story. So glare occurs in 2 ways. The lumen output is too high, and it creates a phototopic response, or the lumen ratios are too high, where the range of lumens in the visual environment is too large. So essentially, it's, those 2. Discomfort glare is caused by 4 factors. The luminance of the glare source. So like what we said before, too much lumens out of the point source. Size of the glare source. So again, the bigger the size, the more lumens it can actually put out. So this is really important for real life application in terms that the larger the light source, the more lumens it should have in theory, and it will be less painful to the eye the bigger, and that's why you see a lot more like large diffused light sources. The position of the glare source, and this is really important. You can see this in the diagram on the right. So you want to say the position of the glare, and a good rule of thumb for that is to try to avoid having glare sources within a 45-degree view range, as this is considered a glare zone. So essentially, like if you're sitting at your desk, you create like a home office and you've got a light source, you do not want to be within a 45-degree range of that light source. It needs to be behind you, or it needs to be on the side of you. Can't put that fixture above you, or you're going to get glare on your computer screen, which is very annoying. So it's also something to consider for where you position your desk to windows and whatnot in terms of light actually coming in. You don't want to have a 45-degree from the light source coming into the window. And then, of course, the luminance of the background. So disability glare is the reduction in visibility caused by intense light sources in the field, while discomfort glare is the sensation or annoyance or pain induced by overly bright sources. So it's just essentially like disability glare, no glare. So you can see this, and it's all available in the IES handbook. So how do we avoid light in like real life situations? So a few ways to avoid it is integrating dimmers. So this is really important. Control systems, control systems, control systems. Integrating dimmers, lower and shield light sources. So essentially excellent glare shields, louvers, etc. And then with downlights, you've got your snoots and your pinholes, etc. and shields. So these accessories are so important when you guys are looking at specifications for lighting fixtures, downlights, etc. Is having the ability to shield the fixture with these accessories. And most manufacturers today will have these options, but you really want to make sure that this is all considered when you're actually specifying the light sources. So louvers and shields, this is really popular for linear fixtures, especially when we're doing like perimeter lighting in a home environment, grazing a wall, etc. Is that these louvers and glare shields sort of create it so that you're not seeing the light from the fixture, you're seeing the effect. And they come really beautiful now. They come in all different finishes and whatnot. Some are more efficient than others, but the ultimate goal is that you're not looking directly into the sources. Like you want to always have everything either like diffused and recessed, or you want to have everything like shielded. That's essentially what we're trying to cover here in this slide. So here's two different types of downlights. One has a faceted reflector, which you can see on the left side, and the other has a diffuser with a white baffle. Faceted reflectors direct the light where you want it to go, catching the light, hence no glare. And diffusers and white baffles catch the light and make it visible to direct lines of sight in our space. So especially in a downlight application, these types of downlights are considered to be glare bombs, unless you dim them way down or they're completely out of your normal viewing angle, such as a really tall ceiling. So like the takeaway here is like number 14, what you see here with the diffused white baffle, like this solves the glare challenge because it's completely diffused, but it's really ugly and nobody wants to look at, you don't want to look at it, and especially at full output, you'll essentially have some considerable glare unless it's in a very tall ceiling. The faceted reflectors and deep recession of the LED source is essentially how you create that quiet ceiling that everyone's always talking about. So safety can be divided into three categories. So we're moving on to the safety part now. Electrical safety, which is following all your electrical codes. Emergency lighting, so example, like typically 1 foot candle on egress path. And the perception of safety, which is equally important, a feeling of safety. The IES handbook provides lighting recommendations. There's also ASHRAE, IES, and then you also have to consider your local, regional, and federal codes as well. but they all are important.
Sorry, what is IES again?
Oh, IES is International Electrical Standards, I believe. Oh, no, sorry. I'm sorry. I take that back. It's Illuminating Engineering Society. If you want, I can show you. I have all their books here. But they're massive. It's like a 5,000 page giant book that they give out I think every year it comes out. So, okay, so the next here is in terms of lighting level recommendations, IES, and generally IES is the governing body or like the responsible national body for writing all the electrical national codes. They're also in charge of like Title 24, NJ, and all that. That all comes out from the IES. So in terms of lighting levels, IES handbook provides recommended lighting levels. For example, informal dining, like what you see on the far right, shows, although it kind of looks more like an office application, but it was supposed to be informal dining, are recommended for horizontal planes. So you should have like 10-foot candles on the surface, are recommended on the horizontal plane. And all of this information is available in the IES handbook. I think there's also a digital one as well, but you can pull all this, it's all available to you. And then a common safety interior and exterior lighting. So a common safety lighting application has to do with navigating spaces safely, and stairs are one of the most difficult spaces in terms of safety and how to actually light them. There's a few handrail applications that I'm showing here. Some of them look more decorative, but essentially you have to be delivering the recommended foot candles. And it's different for indoor versus exterior environments. But there's three types. I mean, there's the decorative aspect, and then there's, of course, the desired foot candles. And I believe it's 1 foot candle on egress path lighting for exterior. So a common safety application has to deal with like the next one is exterior lighting environments. And we essentially like broke them out into 3 different, there's sports related, public spaces, and private spaces. Sports related activities are generally recommended by the IES. So that's like a national thing, how you light that. It's not really like a code thing, like a local code thing. Public spaces are IES lighting levels and local code. So my local codes in California are going to be different than, let's say, in California versus like New York. And then your private spaces, which are navigation, like what we talked about before, and local code. So IES, a little bit, you can find some recommendations in the IES handbook, but generally private spaces are more about navigating and local code. Perception for safety. Now this is an important thing, and I just talked about it before, but your perceived safety is really, really important. It gives you the idea that, you know, there's spatial recognition, there's glare control, and social interaction. So there's 3 aspects to consider, and we're showing the same application, which I think is like a path, and it looks like it's in Singapore. And essentially they put street lamps up, which are creating like what we talked about, glare bombs. This is like a classic example of a glare bomb. And it's not actually putting the desired foot candles for egress lighting. It's not actually providing a well-lit path. Whereas the right picture is showing handrail lighting instead of these. There's no glare, and there's a lot more delivered foot candles on the path. So you would think, you know, like street lamps would be a lot smarter of a way to light it, but in reality, it's not. And they're not actually they're just creating glare, probably not complying with dark sky, and they're just not working. I don't know if you guys can see that in those pictures. So the perception of safety on a social level has to do with our ability to know the intention of others in the public space, especially on the private area that you see here, which is like 12 feet away. 2-foot distance is critical for us, and like our private zone ends and the social zone begins. And this is the distance that allows a fight or flight scenario. So at the distance, it's vital for lighting to provide necessary light levels required for facial recognition. So this is really, really important. And when you're within 2 feet, you need enough light to be able to see that person 2 feet from you. And this is what gives us our feeling of safety or not safe. So there's a theory from John Flynn at Kent State University that experience of lighted spaces is a measurable experience. So this study reinforces and articulates the need for engineers and designers to be sensitive to the idea of lighting functions as the visual sensation and experiences are manipulated by the design intentionally or unintentionally. The three-dimensional graphic, which you see on the right, shows how the point of impression is located in a uniform, non-uniform, overhead, perimeter, and bright, dim spaces. So like essentially it's looking at uniform, non-uniform, overhead versus perimeter lighting and bright or dim. And we're going to just show a couple of different applications. So this is a uniform application, 2 different ways to light the space, point sources, giving complete uniformity. So they're essentially spaced equal distance from each other and from the perimeter walls. And then there's like direct view and wall grazing in a linear application. And they create like a very different feel, although the overall impression for these 2 slides are that you're getting a well-lit space, like a uniform well-lit space, just different effects. Then there's the impression of overhead non-uniformity and the impression of perimeter non-uniformity. Again, now we're talking like we got dark spots and stuff. It's not ideal. Now we're going to analyze the same architectural space with different perceptual lighting effects by Flynn's model. So the first is the impression of perceptual clarity. So basically, it's mostly uniform lighting, perimeter and overhead lighting, bright illumination, and we can clearly render and understand the space. So this is an excellent design. Then you've got the next, which is hazy, which is, again, the perception of the space is achieved by non-uniform lighting, mostly overhead, and it's dim, and it's rendered, and it's hard to sort of understand what we're looking at. Then you've got the creation of creating a larger space, which we talked about a little bit earlier, which is essentially lighting one of the back walls that would give you the feeling that the space is much larger. It's mostly bright, and it's mostly uniform. And then this is a small space, so now you're like creating like the feeling of a small space, non-uniform lighting, overhead lighting, mostly dim, high contrast, lack of illumination. So this is what we call like theatrical lighting, where you've got a very high contrast of your dark to your light. And then this is your public, which is essentially mostly uniform ambient lighting, overhead, peripheral lighting, mostly bright. And then we're on to the last, which is your private space, which is non-uniform lighting, mostly overhead lighting, dim light levels. How to light? So the lighting design can be achieved, the desired ambiance or lighting intention by using a couple of different techniques. And this is like applicable for any application. Different lighting strategies. So essentially what we just talked about, which is peripheral lighting versus overhead lighting versus that theatrical effect versus some general ambient lighting. Color temperatures. So color temperatures have their place in each application. Hospitals are generally going to be your 35 to 4,000. Your, dining lighting is usually about 27K, 2,700K, et cetera. And then how to incorporate daylight strategies like as well, like daylight harvesting and whatnot. And then selecting the correct beam angles for what you're trying to achieve. So if we're trying to like light a piece of art on a wall, we want the correct beam angle for that and not light the entire space. We want to create like a theatrical effect. So, so as part of lighting design, you may pick a fixed color temperature, dynamic white or warm dim technology. So there's 3 different aspects here. One of the most popular, obviously, is of course choosing the right color temperature for your application. But a lot of the time we want to do either a warm dim or tunable white. Warm dim is essentially one of the most popular that we see for residential and also for dining and restaurants, is essentially mimicking that incandescent effect of 3K, and then as you dim it down, going down to 18K. That's your, and essentially it's done by like multiple LEDs in the point source with different CCTs, and then the control system that essentially allows you to dim it down, and as it dims, it warms. Tunable white is that same concept. It's just that you have a wider range of color temperature, and you can dial in your color and your output. So essentially, you're not mimicking an incandescent, but you're using the right white lighting for the task. So for instance, if we're cleaning, I want to turn it on to 6000K so I can see all the surfaces as bright as possible, and then maybe warm it down for dining down to 27K, et cetera. So you have a lot of different options using different LEDs and control systems for warm, dim, tunable white, and for static white options for just standard dimming on static white. So this is a great example of color temperature in the correct environment. The left image is a fast food restaurant, and it's very well lit, general ambient lighting. There's not really layers of light here. It's a completely well lit space. And what it's kind of telling you is you want to be alert, you want to order fast, you want to get out, and we want to be efficient. The next one on the far right is an example of like a high-end restaurant in which there's like sort of pockets of light, layers of light. It's much warmer. It's mimicking almost like an incandescent feel, and it's to slow you down and to relax. So it's essentially two different lighting schemes to achieve two very different things. Now we're going to talk about dark sky. So, I mean, we don't really see this very often anymore, at least not in Florida. There may be many places still that can see this, but the reason we don't see this anymore is really due to light pollution and poor outdoor lighting, which is wasting energy, and it is also creating this like loss of dark or no visible stars. So this is not just a problem in terms of wanting to see stars. It's actually an overall problem that disrupts plant growth. It disrupts the quality and the life of land and sea animals, migrating birds, sea turtles, et cetera. And it also can cause accidents like on the road and whatnot. So it's actually it has a lot of very, very bad effects on top of wasted energy, which is another major. Okay. Oh, wait. Okay. So this is so bright light also affects humans, and this is really important. Glare from poorly designed light fixtures cause accidents, like I said before, and it also disrupts our circadian rhythm, our sleep patterns, and it's also known in a lot of the areas where there is a lot of light pollution. It's also known to now cause more cancers, specifically like endocrine cancers such as breast, ovarian, prostate. So it's a very serious problem. So poor outdoor lighting, it can lead to light. Obviously, there's the light pollution, and then there's a couple different scales of lighting in terms of exterior. One is called the Bortle scale, which I was not familiar with, but anyone that does like facade lighting has to be aware of what codes their city aims for. Like a major city is never going to aim for a 1, but they can't be at an 8 or 9. So it's just important to be aware of that. And then it's showing you, the images on the left are showing you like examples of worse, bad, good, and better, which is essentially shielding again, like we said. You know, you want to make sure that the light source is not lighting everything in its surrounding, but exactly where the light needs to go. So if you've got like a street lamp, it doesn't need to light everything, it needs to light the pathway. There's a terminology called bug lighting, which is developed by, again, the IES. And the bug lighting stands for backlight, uplight, and glare, which is divided into subzones to be calculated. there is a lot of information on this topic in the IS, but I just wanted to briefly touch on this because you will see when you're looking at exterior lighting and outdoor lighting, you will see the terminology bug lighting quite everywhere, and it refers to backlighting, uplighting, and glare, and it shows you the calculations on the far right in terms of like where you need to fall, and there's each city has its own numbers. So one of the good news about lighting pollution, unlike air pollution, is that it is reversible, and we can fix this. So what can we do? We need to use light fixtures that have shields, like we talked about, and optics. When possible, try to automate the lighting so that there's motion sensors. Use lighting where and when it's needed, not where it's not needed, and using blinds to keep light inside, not outside. As we come to learn, artificial lighting has its impact on wildlife, like I talked about before. Example, turtles suffer from alterations with artificial lighting or built environments. Some codes, such as Florida Wildlife Conservation, includes them in the restrictions and guidelines. And there's quite a bit of guidelines related to turtle lighting. So if you ever are driving along the coast, you can see amber lighting quite everywhere, and it's quite low and almost too dark. That's on purpose. And it has to do with keeping the wavelengths low, shielding your light, and again, keeping it low. So now we're going to move on to some fun stuff. We're going to talk on the residential side of things, which is essentially how to light in layers for residential applications. So here we're showing the lights turned on for this project. Overall, we're looking at a glare-free environment with a warm white lighting. And ideally, all the lighting would have warm dim technology to allow us to have certain moments where you really have low candlelight warm light effects. And then on the next slides, we're going to analyze the different strategies and layers of light in the space. So in this slide, you're going to see we're using linear lighting to light this bookshelf. And you can see the light sources are hidden. So essentially, we're like you're seeing the effect, not the source, which is ideally the goal with most linear lighting, unless it's direct view for different applications. And now we're showing accent lighting for artwork. Again, what we talked about earlier, which is like the theatrical effect, which is, essentially creating like a very high ratio of, let's say, like 12 and up, 12:1 ratio for lighting artwork to create a theatrical environment. And notice how we're using faceted reflectors to avoid glare. And we've got downlights in the living room that are generating a nice pool of light on the horizontal plane. Notice how the light source is deep into the fixture and faceted reflectors to avoid glare. And then you've got decorative table lighting. And floor lamps to provide a light fill that contributes to the space. So it's like a soft omnidirectional lighting in this space. And you've got linear lighting to integrate it into the handrail. And there's a louver on the linear fixture to help avoid direct line of sight, like we talked about, like putting that glare shield. So we're like putting together a lot of what we talked about, which is essentially like recessing the fixtures, glare shields, louvers, et cetera, so that you're not seeing the source, you're seeing the effect. Everything is like a quiet feeling, quiet stairwell, et cetera. Then you've got downlights over the dining table to create a nice pool of light over the table. Again, deep shielded light sources with faceted reflectors to avoid glare. And again, accent lighting for artwork that we talked about earlier. Notice again that faceted reflectors to avoid glare. And then accent lighting for floral display. Again, the theatrical effect. Once again, notice we're using deep faceted reflectors and how the light source lives deeply in the light fixture. And outdoor rated linear lighting integrated into a glare-free under bench detail. And now that we understand the logic behind the lighting, we can see the whole lighting scheme turned on. These layers of light will work in conjunction with the lighting controls and would allow us to create light scenes and levels for specific activities like working, dining, strolling in our garden, etc. You can see the living room is all on, and you can see the dining room is all on, and you can see the outdoor view all on. And And that is it. Thank you so much.
Wow, that was fascinating. Actually, so glad that we had time to go through this again because it was definitely missing some of the detail. I want to back up to some of the earlier things that you mentioned, Rena. DC versus AC. I think I grasped the idea that we have a 60 cycle alternating current, and when we're on the forward phase and the reverse phase, you can be without current, so it flashes and can give a strobe effect. I think Shannon's theorem is the electrical engineering theorem that describes the same phenomena. But what I don't understand is all LEDs are DC by nature, right? So you have a transformer that is converting AC to DC in 100% of the cases.
No.
You are starting to make a point about, DC is going to be a cleaner dimming because you don't have the lack of power during the 60 where 60 cycle crosses the 0 point. But if you're going through a transformer and everything is DC at the end of the day, what does that mean in a practical sense to an installer?
So a lot of fixtures, like specifically linear, a lot of fixtures are actually now considered line voltage. So it's direct AC into the fixture. There's a lot of modules now, like LED light modules, that are designed as a direct AC. So, and the purpose behind that is it's an easier install. It's a lot less expensive and it's an easier install. And it's actually very typical in like linear applications where you've got long runs. Generally, you'll get integrators like contractors and whatnot that want to put line voltage or AC direct 120 in because it's an easier install. And in many applications, it's fine, especially if it's like outdoor, it's not dimming, that kind of thing. The minute that you need to introduce dimming, you're like lucky a lot of the time to get to below 20% without seeing visible flicker. It's a real problem. And it's kind of like an argument that the lighting designer has to argue with the end user and the contractor, because often the contractor has the ear of the end user and they're saying, you want this is an easier, cleaner install, especially if there's a lot of like continuous linear runs. But in a lot of cases, it just doesn't make sense because the flicker is so awful that, sometimes it's just much, much better to bring in, a low voltage system. And most downlights and whatnot are low voltage and stuff. So, it's not such an issue with the downlight, but it is quite the argument for linear is, do you want direct AC or do you want like a low voltage system? And there are some now that, oh, sorry, go ahead.
Yeah, sorry to interrupt. So are you saying that you would not want an LED eye with an integrated driver? You want an external driver so that the fixture is pure DC and you have a higher powered transformer that is absorbing the waveform somewhere else mounted separately?
Not in every application, but in many. Like in any application where we need a dim, like I would never do line voltage or direct AC in anywhere where I need to dim. And I wouldn't do it in like anywhere where I'm going to be for a long period of time. Like, let's say, like if I'm in a hotel room or if I'm in my own home or if I'm in even like an office environment, I don't think I would want to sit in that for 8 hours. There's nothing wrong with it when you're doing with landscape lighting and whatnot. In fact, I think it's actually more efficient for those types of applications, especially if you don't need to dim. But I tend to think that you get much better results with a DC or low voltage system for most applications.
The problem comes with retrofit, right? I mean, how do you retrofit a DC only system when all of your overhead lighting started out direct AC? You'd have to tear open your walls.
Yeah, it's tricky. I mean, now there are quite a bit of excellent retrofit downlights and whatnot, like that you can find. But again, I think the dimming quality on right now, as the technology stands, I think that you see too much, like there's too much frequency when you're dimming, and it becomes it's not pleasant. But there are DC like retrofit solutions, and there are some excellent ones on the market for downlights and whatnot.
I'll have to look into that because that is interesting. The other thing you were mentioning was this whole bit about glare, and like I'm sitting in an office right now and I have a skylight, and it's a solitude, right? It goes out to the outside, and if you look on the roof, it looks like a solarium or whatever they call that thing, but it reflects the light through a reflective tube, and then it comes out. And I don't really have a lot of control over it, but I have noticed, and I'm not at the 45; it's like right on top of me, but it doesn't create a glare on my screens. But I'm wondering, like where I'm thinking of here is when we set up residential AV environments where you're looking at a television. A lot of times we don't have control over where the lights are. The lights are just there. They were there when we got into the room. And they're not zoned where I can turn the ones that are right over the TV off. And if I dim, then I'm dimming the entire ceiling and that. So in that case, would you be adding light shields? Is that like really the only way out?
Well, there's a couple things. We were talking about with the skylight, a tricky problem. I need to think that one through a little bit. I mean, there's definitely, yeah, I mean, there's some shading options and whatnot. I'm not super familiar in that side of things, but I'm sure I can find out for you. I think that they probably have some excellent solutions. I just don't know when it comes to skylights. It's just not my area of expertise. But I do think that where you set up and your tasks have to be in consideration to where the skylight is. If it's right above you, it should probably be okay. But I think that it's also going to matter at what point in the day and where the sun is in relation to where you are. When it comes to zones and whatnot, where you were talking about with downlights, that is like a perfect example of why zoning and an excellent control specialist is so important, because there's nothing more annoying than when you're turning, you need one light and you got to turn on 14 for one tiny source. Zoning is so critical, and it's so important when you're mapping out your lighting scenarios, which lights are for what detail. That's critical, and that is my area. So I could tell you that, essentially you want to create, again, like we talked about, layers of light, and that's layers of zones, because it's totally inappropriate to turn on every light in your home when you just need a little reading lab, or, everyone's sitting in an open environment and everyone is sitting in, the living room. There's no reason for all your kitchen lights and everything else to be on. In fact, it creates almost like an impersonal feel. You want to have light that's exactly where you want it for the task that you're trying to do, not to light the whole space.
Yeah, no, I totally agree. And if you think about a home theater, and I mean an actual real theater, not like a family room. I mean a dedicated home theater. I always recommend that you have lighting over the seating, but not where it's reflecting onto the screen, so that somebody could be sitting there, let's say eating popcorn, and you drop popcorn on your lap, you can find it, but you're not casting shadows onto the screen. And I would say the same thing applies in a bedroom, or in a family room or whatever, where you want to light up the seating areas, but you don't want that glare, putting a little hot spot reflecting off of your flat screen panel. You just end up, that's the only thing you end up seeing. Once you notice it, it's like all you see is that little spot,
Yeah.
So yeah. I totally agree with that. And adding the layers in a retrofit is where some of the newer technologies that we heard about last week and the week before come into play, where you can create zones even though the house wasn't originally wired that way.
Is that through PoE? Is that?
Well, not necessarily power over Ethernet, but would be like Ketra would be an example, right? Where the control of it is in the fixture, so you can send a command to the fixture, and it's still receiving power, but yet it can dim.
Mm-hmm. Got it.
Right.
Okay.
So Yeah, so that's kind of an interesting thing, and I like your description of layers of light. And as in that one study that you did there, where you had all these different features, whether it was task lighting on a table or accent lighting, artwork lighting, and so on. And then as you added them all in, you could see all the various techniques complement each other, but yet set a mood as you kind of went through them. And I was just thinking, those are scenes on a keypad on the wall, that kind of
Mhm.
bring each different layer in and creates a new environment.
Yeah, you're so spot on. I mean, I didn't cover controls in this, but it's 100% controls related. The layers of light is a direct correlation to the control system. So,
Yeah.
because without control, this is nothing. Um, and it's an obvious thing, and I should have actually mentioned it, but it's a real, um, none of this works without that piece.
Right. Well, the other thing that your slide showed me that I've never seen anyone really talk about before is handrail lighting for stairs. And
Mhm.
usually what we see, and going back to residential, which is kind of our focus here, it in a darkened theater, and you're lighting up the steps. And I usually see these cheesy little lights on the side because it's so much easier to put it in the wall during pre-construction than actually integrate it into the step. But that's what I was thinking of when I saw your handrail. Like, how cool is that lighting up? You can see all the steps, not just a spot like where your foot would go. You can see the whole thing. And so like you don't
Mhm.
feel like you're going to trip up or trip down the stairs. And then in a theater, instead of lighting the side, it seems like you should light the entire width of it, and it's shining down and you can see the whole step. Is that what you would recommend?
Absolutely. I personally love handrail lighting much more like when you saw the images of Singapore with the street lamps. I hate street lamps. I think it's like old technology and we're following a form and function. I mean, there's some beautiful ones, but it's generally glare bombs and they're not actually delivering the lumens you want. And I think that handrail lighting is gorgeous. Tends to be a little on the expensive side, especially commercial. And now that we're past the 50 minutes, I can mention Lumini has acquired a company called iLight about a month ago, and they do a full line of like handrail systems, like navigation, direct view, linear for indoor and exterior. And it is, I mean, the offering is just phenomenal. And they have so many options to do what we were showing. But there's also other ways to do it, especially in interior. We have so many options for integrating lighting. There was an application that I think I showed where it was like completely recessed in, and it's like kind of like a drywall solution. I mean, really, it's this is where kind of like design and code meet, and that's it's one of those places because there are quite a bit of code surrounding stair egress and pathway guidance lighting, but with the right solutions, you can really do gorgeous things.
Oh, for sure. I saw one house, it was my favorite one, where they had a lit handrail that was made out of a backlit onyx. I don't know what they paid for it, but
Mm.
it showed all the veins in it and it glowed. And you could just imagine being in that house, at night, finding your way around, and your eyes haven't adjusted, but that is so dim, it's comforting and it guides you. But yeah, it does show everything too at the same time. So it kind of is a little different than flicking on the lights and you got that big huge one that's at the top of the head of the stairs, and like, oh, your eyes start immediately trying to adjust. You're trying to walk at
Hmm.
the same time. Um,
Yeah.
so I really like that effect. I love it outside too. That one that you had outside. What a contrast between the lamps and then lighting up all the different. It's like all of a sudden you could see everything lit up, but you could not see where the light source was. I was looking for it, and I didn't. I really didn't see it. It was all indirect and hidden. Very elegant. I really like that.
Yeah, me too. Me too. It's not my project, that image, but thank you. The one you're talking about, the one that's in the park, right?
Yeah,
The one,
yeah,
yeah,
that the
yeah,
one in
yeah,
the park was, and
yeah.
I'm thinking about residential landscape lighting when I saw that as how to apply those techniques. I like the down lights and the indirect lighting, but also, the drama, the shadows and this and that, and being able to light up, different things that you want to focus on outside without making it look like a public space, to use your terms.
Yes, exactly. Exactly.
One final thing, because I know we're coming up on our hour here. There was a little bullet in one of your slides there that said working at night under bright lights causes cancer. Can you elaborate
Mhm.
on that a bit?
Yeah, I actually read that a few years ago. And I'm a cancer survivor. I'm in remission now for like 18 months. And I can tell you that it's something that my oncologist had told me as well. And it's basically that there is a lot of studies now about disruptive circadian rhythm lighting. And do you know what I mean when I say circadian rhythm lighting? I've been
Yes.
using the term. Okay. So
Yeah.
they're saying that when we are constantly messing with our internal clock, we are effectively lowering our immune system to a handful of different diseases and whatnot, and cancer is like the top of the list. And specifically, it's related to endocrine cancers. So endocrine is like your breast, ovarian, pancreatic. I think there's one more. But essentially, you're lowering your immune response to it, to rogue cells that go through your body and whatnot. I thought it was so interesting. Mainly, I grew up in New York City and then lived in Brooklyn, and there's just lights everywhere, and I'm like, oh well, that must have done it, But I'm an anomaly, like it's not necessarily it's something that we have to be terrified of, but it is something to be aware of. The studies are indicating that, messing with our internal clock, and essentially that's what light pollution does when it pours through our windows all night long in urban environments and whatnot. That is what is essentially messing with our internal clock.
I wonder if they'll do anything about daylight savings switching like we did last weekend, because I can tell you I'm still waking up at the same time, and I haven't adjusted yet, which is odd for me, but like the
Yeah.
last couple of days I've been waking up at like 4:30 in the morning and like, oh my God.
Yeah, no, it's true. But there's also like a lot of different things beyond light pollution and stuff. Like there's like lowering the blue light spectrum in our lighting, which is like the next big push. And there's a handful of other things, like even just reducing your screen time in the evenings. I mean, there's so many different ways to regulate your body clock. So it's not just light pollution, but they are saying that it is a major contributor.
Wow. Poor all those FP&L linemen out there only working at night with massive lights. I can
Yeah,
only imagine that. I mean, that is their job, right? That's what they do.
it's true. It's true. I will tell you that maybe we should all, because of COVID and everything, we should all pick up and move to like Montana or something, But I'm kidding, but you know what I mean.
Yeah. Yeah. Well, that's great. Well, Rena, thank you so much for your time and for your patience in doing this again. I know it was frustrating when we were having the internet glitching, but we got through it, and it was definitely worth doing it again. And I absolutely learned a lot and some new terminology, and thanks for putting it all together and for taking the time to do a redo this afternoon. So thank you very
Thank
much,
you.
and
Thank you
yeah.
for letting me redo. It was really important. So thank you.
Okay, you're very welcome. And so this concludes our Boca Tech Talks, and I look forward to talking to everybody next week.